Hi. Today we're going to talk about the combination lock. Combination lock is a universe program that has two numbers that you're supposed to guess. And at the start, at the start, you see a gray circle. And then if you type something a wrong number, you get to a red circle. And if you type the correct first number, then you get to the point where you're supposed to enter the second number. And again, if you type something wrong, you'll get a red circle. And if you type the right second number, then you'll get to the green number. So this is combination lock program. It's supposed to represent uh, a two combination, like a master lock, dial lock, which of course these aren't seen in the real world because they're too easy to guess. But um, I think this will be plenty to show the ideas. So the model we're going to be using is a state number. That's the bottom half. And then, so 0 represents you're ready to fill in N1. And then 1, 2, 3, 4. And then we've got N1 and N2 are the actual numbers that you're supposed to guess. And then we put last to represent the last number that you typed. So that could be one of the numbers that you guessed, or it might not be. And then T is going to be um, a number to represent the countdown of the lockout before you get um, back to being able to enter the numbers again. So we'll talk our way through it, but there's going to be a couple of strange, um, like a couple of things that happen. One of the things that's going to happen is that we're only going to have positive numbers from 1 to whatever. And if we enter a 0, that's going to represent that they haven't actually started to enter their number yet. Okay, so we've got a state diagram here. So state 0 is ready to fill in N1. And then if you get it right, you go to state 2 and get right again. You get to state 4. That's going to be unlocked. And if you get it wrong, you're going to go either to state 1 for lockout or 3 for lockout. I guess honestly, 1 and 3 they could be the same thing, but the reason that they're different is because the place that you're going to show the last number that they entered is going to be different. It's either they're going to be the first one or the second one. Okay, so we'll work our way through this step by step, and you can see everything about how it gets done. All right, let's go and take a look at the actual animation. All right, so first thing I'm going to do is I'm going to write the guesser part. And so this is the guesser client. This is basically a chat client. So the model here is a number, and the message that gets sent is a number when you hit enter. Okay. So there's probably going to be several things tricky about this, but the draw handler is not one of them for the guesser. Guesser is just going to show the numbers as you enter them, and then when you hit enter, it's going to do the sending. So let's see. So I'm expecting this guesser that I wrote to work just fine. Yep. All right. No big deal. I'm not sure at this point if we want to have special handling for 0 or not. If you have 0, it's supposed to represent nothing entered. So maybe like we'll add in a conditional later on if we care to indicate that the blank or something instead of 0. Okay, so this looks fine. I'm going to make at least one of these into a check expect. Let's see, guesser. There, now I have one check expect. That seems like enough for the draw handler, for the guessing client. Now we have to do the guesser key handler and key handler going to take in a number and a key, and my like my skeleton, I'm just going to write n, so no change. But actually what I want to have happen is I'm going to call this guesser key handler because I think we're going to end up having everything in one file. So guesser key handler, let's say so far you had 3 and then you type the number 6. What's supposed to happen is you get 36. And say you haven't typed anything yet and then you type 3. What's supposed to happen is the answer is 3. Fortunately, I recognize this is the answer equals old model times 10 plus value of the key. Okay. And then I think we should um, say what happens when the model is, say, 36 and they hit the A key. I want that to be 36, so not an error. And when the model is 36 and they hit the enter key, then what I want to have happen is make a package 0 for the new model, so get rid of the number, and we're going to send the message 36. All right, so this is looking pretty reasonable to me. So let's see. We've got a couple things to take care of here. Which one do you want to do first? Well, let's see. So I'll leave a space for the most common case, which is type a digit. And then let's see, the next space is going to be you hit the enter key. And that's going to be 0 and send the model number. And then otherwise, we're just going to leave the model number untouched. So now I just have to write down the situation for in the first case. So what I want to do on the left-hand side is make sure that the thing that's been hit is a number. And the way I'm going to do that is see if key is between 0 and 9. And then and then like I wrote down below, you multiply the old model by 10 and add the value of the key, so string to number k. All right, I think that's going to take care of our guesser key handler. Yes, all 5 tests passed, that's great. So now I've got a key handler and a draw handler. That's really all I need. So guesser, big bang. I'm not even sure. Well, let's take in a starting n. And what we're expecting to do is big bang, start n, name, guesser. Let's see, register, localhost. And then on draw, we're going to use the guesser draw handler. Whoops. And sorry, that's usually called to draw. And on key, guesser key handler. All right. So, and here's our little notes about the key handler. All right, so I think that's enough. I guess, yeah, we already wrote checks for it. So I really think that we have this under control. So that's the end of the client. There we go. Now we're going to spend a little more time trying to make the server, the lock part. So this is the locker part. So this is another one of the quote unquote clients. This one has a more complicated setup. So let's see, define struct lock. It's going to take in a state S, state, number 1, number 2, last number, and T. So the lock structure, state in numbers 0 through 4, and N1 and N2, positive numbers representing the combination. And then last is a number, the last guess you received, 0 for none. And T, the number, which is the number of seconds to wait before you can guess again. Wow, so this is a lot of fields. Let me put the definition below the words. So with this many fields, I think we want an updater, a set of updater functions. So update lock, old, and then new value. Oh, and let's see. So old, the new value will change, update lock X. And we're going to fill in lock state, N1, N2, last, and T as different X's. So let's see. So the way you make updaters is you write make lock, and then lock state old, lock N1 old, lock N2 old, lock last old, lock T old. So it didn't use the new value at all, but that's because we intend to make multiple versions of this. So for example, when you do lock state, instead of doing lock state old, put the new value there. And let's see, instead of, I think last is going to be another useful one to replace. Oops, that's the new value. And then another one we're going to need to do a lot is T. So in this T, get the new value. Okay. And in fact, since I know that we're going to be changing the time, I think maybe we should also make one like that, that's just changing the time. So instead of update lock, we'll have change lock T for old and the change amount. And the plan here is going to update lock T, old, and then we're going to add the change amount to lock T of the old. So this will add the change to the old value. You can see these look like they're probably going to be useful. So far, so good. Let's see if we can hide these for a little bit. Okay. So I'm going to give them little names in a comment and collapse them. Look at them. What do you think of that? Update lock state. That'll get collapsed, and then update lock last. And we might need some more of these, but not right now. Not right now. Okay, so let's make these things go away so we don't have to think about them while we do the rest of our writing. Go. Okay, so now I've got some updater functions. Now I think the thing to do is we're going to write the draw handler. The draw handler is not as easily as the other ones. It's going to take some experimentation. Let's see, do we have a background yet? Oh, we have a background. We could use the same background. That'll work fine. One of the things that's going to make this a little bit annoying is that I have several things going on. All right, let's go take a look. So first of all, on the right-hand side, you see this state and circle color. So I've got like 0 gray, 1 red, 2 gray. So I'm going to put that into my program. Choose color. It's going to take in a number, which is the state. And it's going to be a big conditional. Is the state 0? Then let's say dark gray. And is the state 1? That's red. And I'm just following the list that I showed. Is the state 2? That's a gray, so not dark gray. And is the state 3? Oh, I forgot. Dim. Dim gray is the, I believe, the name. So state 3 is red. And state 4 is green. So let's see, let's get our state circle. It's going to be maybe 50 solid and choose color. And we're going to test this. So the testing, seems hard to mess up. So I'm expecting to see 4 different circles, and the dark gray is hopefully going to be darker than the regular gray. Yep, looks good. So that's what I'm expecting to see. Wonderful. There wasn't really enough here to mess up. So I'm going to pick a single check expect. Maybe we should have a different one, a different else or something. But well, I guess we'll hope that nothing bad happens, and we'll just get an error. That happens. Oh, state. This is state 0. I'm not encouraging you to comment out your check expects, but I am going to comment out the examples. Okay, so now I've got a color. Now I need to show the numbers. So show number n, and that's just going to convert the number to string and show it at like 50 point black. And then I'll need a dash. And I think the dash is going, well, we'll make up a size for it and we'll try it out. 30 by 5 solid black. So what I'm thinking I'm going to see is, so number 36 dash show num 20. And let's take a look at that and see what it looks like. I mean, doesn't look great, but doesn't look super bad. I guess the thing that surprises me is how low down the rectangle is. That's not really where I expected the center of the rectangle to be. So I'm not really sure what we're going to do about that. Well, I think we'll just leave it for now. And we'll call this the function that renders the numbers. Oh, I forgot a feature, which is if the number is 0, we don't want to see it. So I think the way we'll solve that problem is actually by making the color depend on the number, and we'll just make the color transparent if the number is 0. So is the number 0 transparent? Otherwise black. I mean, this is a little bit ugly. I don't feel like you should be really putting conditionals all the way inside your text like this, but it works. So we'll double check on this, make sure that if I put in a 0 for the second number, nothing shows up. And if I put 0 for both numbers, then we just see the dash. All right, like, it's okay. Maybe each number should appear on a certain size background. So that looks okay. Let's overlay this much on a slightly larger background, like maybe square 70, just some invisible square. No, hey, those don't look so bad at all. I think that's perfectly acceptable. All right, so now we've got part of our draw handler, the show numbers part, that show single number, and I've tested the setup for showing two numbers, but I haven't shown it. I haven't written it yet. Show nums n1 and n2, and we're just going to rip off this code right here. Should be exactly the same. First number is n1. The second number is n2, and we should be in business. And I'm expecting to see the same thing as I got earlier. Okay, it looks good to me. So here, we'll lock this in as that's our plan. So now I've got the part of the draw handler, and I've also got the state circle. So I think the actual draw handler for the lock draw handler. Oof. There might be some other cases we get to later, but so the lock draw handler is going to take in a model, and it's just going to be show nums, and then lock n1 of the model, and lock n2 of the model. And then we'll discover later the rest of it. This probably needs to be tested. State, does state come first? Here we go. I'm definitely going to save this example and use it in a real check expect. Yeah, okay. Example lock one. So here's my example lock one. Whoops. And let's see if we can get a decent check there. Again, same thing. Okay. And I expect we're going to come back later and have it do different things. Oh, shoot. That is not what's supposed to happen. Let me comment out this check for now. Actually, we're supposed to put the show numbers on top, and then we have to put this status circle underneath. So it's called state circle. Lock state now. And we'll see how this looks. So I'm going to run lock draw handler example lock one. Oh, it's got both numbers and all right. So that part looks good. Beautiful, actually. But now I think we better think about what happens about in some other cases. So let's say you are in state two, which means you got the first one right, and you're working on the second one. This is example lock two. In this one, since we're in state two, I'm expecting to see a gray circle and 36 filled in, but not the next number. All right. So far, so good. I kind of feel like maybe that's all that it takes. All right. So, okay, so we've got a test here for the second one. Good enough. And maybe it would look better if we put the numbers in an outline box? Maybe it would. Let's see. Square, solid, transparent. How about outline black? See if that looks any better. Of course, all my tests are going to fail. But looks pretty decent, honestly. So let's see about, what do you think? Updating some of these values. So show nums 3620. Yeah, that's perfectly good. I like those better. So I'm going to go with the boxes. And then let's get this one updated. Okay, and one more test to update. Yeah, okay. The gap between the circle and the numbers now kind of shows that it's not perfect, but we'll live. Okay, so now I believe that we pass all the tests again. Shoot. Okay. So we've got a draw handler for the combination lock, and we've got the updater functions. And now I think we need to write the receive handler. So the receive handler is a little bit tricky. It takes in a lock, which is a model, and it takes in a message, which in this case is just going to be a number. Maybe I should call it number, which is the message. And it's supposed to output the new model, which is the lock. All right, well, model and message. So I've made its dummy skeleton for the receive handler. And now let's see if we can write some check expects. The first thing is we need a lock. What if, oh, I see. The N1 and the N2 are really supposed to be the correct answers for the lock and not the actual answers. Well, that's going to make this a whole lot harder to write the draw handler. So, oof. Let me put this on hold for a minute, and we're going to go back and fix this misconception with the draw handler. So we're all good for the show nums and all that. But in the actual draw handler, I need to be putting different things here, depending on what the lock state is. So, I'm going to write pick what to show lock state M and the two numbers. Okay, so I'm going to need a pick what to show function. Takes in a number for the state, number N1, number N2, and okay. So now we're just going to go and it's supposed to output some kind of show nums image. Okay. Oh, so this only has the correct answers. But for some of these, we're actually going to need the incorrect answer as well. So number last incorrect. So I'll add the last incorrect down here as well. Lock last. Okay. So now so I will start up with the empty image and we'll figure out what we want to write. Pick what to show. So when the state is 0, that means you're ready to fill in N1. That means we're not showing anything. So I expect the rest of the numbers to be 0. So doesn't matter, doesn't matter, doesn't matter. And that's going to do show num 0, 0. So nothing has been guessed. So state 1, that's the lockout. And the first number was guessed wrong. So it doesn't matter what you put for the first number, but the last incorrect number is going to be the one that shows. In state 2, I'm just looking at the chart that I made earlier. State 2, I'll write it down here for you so you can follow more easily. State equals 2 means N1 is correct, ready for N2. So that means, here, I'm going to make these numbers higher so you can't confuse them with the numbers for the state. Okay. So I'm ready for N2, and N1 is correct. That means I haven't shown N2 yet. So that's show nums. First number is correct, and we're waiting for the second number. State equals 3 means N2 is wrong, but N1 is correct. So 2, state 3, 20, 30, 40. So that's going to be the first number is correct, and then show the last number being incorrect. State equals 4 means N2 is correct. And we ignore the last incorrect answer. All right, so these are all my check expects. Suppose I could label all of them. State equals 1 means N1 wrong. Okay. So I've got 4 check expects here. Instead of the minus check. Rid of those. And I feel like I should have written these as check expects from the start. So sorry, fast forward this part. We'll get rid of the little arrow in the middle so it doesn't cause any trouble. There. Okay, so now I've got my check expects, and it's just a great big conditional. See how writing the check expects makes it easier? So it actually looks to me like state is 0. Then what you do is show nums 0, 0. How about if state is 1? And then I better show nums n. 1 is the incorrect state. Go with that one. How about when the state is 2? So then I'm supposed to show N1 and 0. When the state is 3, I'm supposed to show nums N1 and the last incorrect. And when the state is 4, N1 and N2. Shoot. And I feel like it should be else error. Pick what to show. Bad state. Okay, so I believe that our pick what to show will now show the correct thing. And I think it will be consistent with what we have everywhere else. So I'm not expecting more checks to fail. Phew, all 14 tests passed. That was reassuring. So I've got I'll pick what to show set up so that when you're in a state that one of the answers is incorrect, you show the last incorrect thing that was sent. Okay, so we've got, um, so now we're working on the receive handler. And in the receive handler, going to be pretty similar. So if you're in state 0, regardless of what the last thing was sent was, and let's say you receive wrong number, then what you're expecting to do is go to state 1, which is lockout. Don't change that correct combination. 15 was the last incorrect one. Uh-oh, all my locks are missing a time. We better check on this. Where's the structure? State, N1, N2, last, and T. 3, 4, 5. I'm really surprised those tests passed. So none of these have a lockout. Oh, because this is there's nowhere actually that works with the lockout part of the state. Shoot. So this will be okay. It's not wrong yet because I wasn't actually doing make lock. Except for, yeah, it wasn't. I was just writing the parts of the make lock. Okay, so 15, the parts of the make lock, in case you missed it, there was a last number and then there's a cooldown. So in this case, I'm going to go to the top of the file and define a cooldown for the lock animation. So 5 seconds for a cooldown before you can escape. And we'll take care of that in the tick handler. Okay, so if you're in the state 0 and you guess wrong, you end up in state 1, which is error, with a cooldown. If you're in state 0 and you guess correctly, then you're in state 2. And I guess cooldown is 0. Okay. If you're in state, well, let's see, now we have to, whoops, let's say no cooldown. I'm missing all these cooldown times. But I have to set the cooldown to 0. Otherwise, people won't, otherwise the receive handler should just reject the message. So let's see. We've got the wrong guess for the first one, the right guess for the first one. And then we need to figure out the right guess for the second one. Oh no, wrong guess for the second one. So that puts you in state 3 with the wrong guess and the cooldown. And we could be in state 2 and they get the right answer, the right unlock code. So it seems to me that's going to put us in state 4 and with no cooldown. Okay, and let's see, we could be in state 3, which is the second number is wrong. Oh, let's see. Let's see if we got all these. So in state 0, that means ready to guess the first number. Guess a 15, that's wrong. Get put in state 1 with cooldown. If you're in state 0 and you get the right thing, then you go to state 2 with no cooldown. If you're in state 2, you guess the wrong thing, go to state 3. If you're in state 2, you guess the right thing, then you go to state 4. Well, this seems pretty reasonable to me. I think we can do this. I think those are all the transitions. Oh, I mean, suppose technically, if your cooldown is bigger than 1, that's going to be a problem. So like, sorry, if someone is trying to continue to guess in the cooldown period, even if they're guessing the right number, there's not supposed to be any change at all in the struct because the cooldown prevents you from making any guess at all. Okay. All right, so here we go. Let's see. First of all, first thing let's check is to see if the cooldown is too large, bigger than 0. So if so, just return the model. All right, so now what if you're in state 0? Oh, and you guess the first number. So lock N1 is the correct first number. And that's if that's equal to the message, then you're good. That's a match. So we're going to go on to, whoops, to state 1. Oh, let's see, update state and the new state would be 2, which is, you guessed correctly, the first number, and we're waiting for the second number. And then let's put another correct guess in here. We can do the feel good stuff first. So if you're in state 2 and the message equals lock number 2, go to state 4. Those are the good ones. And then, oof. Then we've got N1 wrong and N2 wrong. So let's see. So we're going to figure out that we got the first one wrong by putting a not in here. So now guess the first number wrong. That's update state M1. And we also want to set the cooldown to be something. Let's see what kind of update function we have for this. Update lock T. So not only do we want to put them in error state, update lock T to be cooldown. Maybe it would be easier if we wrote out the make lock function, but I like the update functions. All right, so this is the updating for getting into state 1, and then we're going to have a similar updating for getting into, oh, I don't think the parentheses here are right. But they are, okay, good. So we're going to, a similar update from state 2. If you don't match N2, then you get into state 3, which is the error state. And I'm not, let's see, I think this error, this is a copy and paste mistake because it was attached to the state 2. All right, so let's double check on this. Oops, sorry, that's a lot of code. Oh no, let's see. That's a lot of code. So let's go back over here and review it before we try our check expecs. So first of all, it says, is the cooldown positive? So you still have a cooldown and you can't do anything in the cooldown period. When the state is 0 and the message matches the first locker number, the first number of the combination, go to state 2. And so you want to check my little diagram here. State 0, you get the right thing, go to state 2. Here you're in state 0, you get the wrong thing, you're supposed to go to state 1. Yes. If you're in state 2 and you get the right thing, you go to state 4. Yep. And if you're in state 2, you get the wrong thing, go to state 3. And in both in the state 3 and state 1, you get your cooldown set. So I'm actually relatively confident that this will pass the check expects. Let's find out. Ooh. Oh no, it's called update lock state. And it should be called update lock state. All right, we'll try it again. Other one. Wow, I missed all of them. Oh no, 4 failures. Oof. Well, let's see what's wrong with them. So the problem is that it is not updating the last value. Well, I feel like the last one, when it was wrong, doesn't matter. But state 1 and 3, it does matter. So that's unfortunate. Let's fix these state 1 and 3. I think the easiest way to do this is we're going to just copy and paste the starter code here. This one does the make lock. All right, so this is all right. So the names are wrong, but this should be cooldown. The lock state is 1. Doesn't change the names. It doesn't change the correct answers. Should change the last guess, the message. All right, this looks pretty reasonable. And we'll do the same thing here in state 3. So get into state 3. Yeah, everything else is the same. All right. And then I don't like the other two, but they don't matter. So there's 2 more check expects, but it doesn't matter what you put for the last incorrect value because in those cases, the last value that was entered was actually correct. So I'll just leave the last incorrect value alone in both of these cases. All right. So now we've got a receive handler. And yeah, well, we're good. We've got a receive handler. We've got a draw handler. So I think that means that we want to make a big bang. And we'll make the new combo. So let's see. Big bang, make lock, state 0, N1 and N2 get set, and no cooldown and no last mistake. To draw, we called it lock draw H. On receive, let's call it receive H. And I guess that's it. So let's get the server running. And then we'll see if we can do the combination lock. Launch many worlds. And so we've got, we want to launch the first one is guess or big bang. And that probably takes in a number, but I don't remember what the number is for. And the lock big bang, which takes in the correct combination. Let's double check on the guesser and see what that number is for. Oh, start number. Yeah, 0 is a good guess for the start number. Okay, let's see what happens. All right, so, well, 36. All right, I think that my Big Bang didn't register. You can see I missed the register. So name lock, register local host. Try it again. You see, you got to watch the state window, the universe window, to helps you figure out stuff like that. All right. So now we go up to the guesser, guess 36. Good. And the color of the universe changed. Oh, we didn't code the cooldown. So 20 is good. Great. Um, try it again. Then we'll have to go back and add the tick handler. So let's see, 36, and then you guess 9. That's incorrect, and you can't guess anymore. Yeah, unfortunate, huh? The end. Okay, so we don't have a tick handler. So lock tick. Old model. And I think this is going to be change lock T. M a negative 0.1. Make sure that has the right name. Change lock T, yes. Okay, so let's add a tick handler in here. Tick, lock, whoops. Tick H maybe. I want to give it a distinctive name. And we'll put the 0.1 there for the delay. Oh. Yeah. All right. Think that'll work. There's nothing here. Oh, there's no way to reset the state from error state to 0 when the time runs out. So let's see. So we actually need to put a conditional in here. So let's see. If the lock time is bigger than 0, subtract 1. Otherwise, we need to do, let's see, update lock state back to state 0, which would let you guess again. And here we go again with the testing. All right, let's see. 36. Oh, that went pretty fast. Oh, I see. This lock tick is not doing its job. It's resetting things too quickly. I guess I shouldn't have rushed in the end here. So there's actually 2 jobs that the lock tick handler has. One, if cooldown is greater than 0, then subtract 0.1. If state equals 1 or state equals 3, those are the error states. Reset to 0 once cooldown is at 0. Otherwise, do nothing. So in this case, either 1 is lock state or 3 is lock state. Then we can reset to state 0 and otherwise do nothing. All right, so now this time I get 36, which is right, 9, which is wrong, 1, 2, 3, 4, 5. Should change back to, oh, yeah, hey, it worked. 36 and 20. I don't think there's a way to escape this state. This is the good state. So I think we're going to have to rerun if we want to see a different state. So I'll try getting the wrong one first. One, two, three, four, five. And then, all right, yeah, that's almost satisfying. Oh, I don't have the backspace key. Unfortunate. My bad luck. All right. So I think that that basically shows the way it goes. Like 36, 20, doors unlocked. That's the end of the combination lock animation. I hope you found this interesting. Let's do a quick review of everything we did, and then we're done. So we wrote two things in this video. First thing we did is we wrote the guesser client, which when it so it's just basically a key handler, the number from 0 to 9. It multiplies the current state by 10 and adds a string to number. When you get a return, make package. Heck, I think we should add in a backspace. And in the backspace, we just quotient the n by 10. And that should get rid of the last number that got typed. We can try that another day. All right, we've got checks for the guesser key handler. We got a function that runs the guesser big bang. We remembered to register and name our big bang. The locker was a little bit more elaborate. It came with this great big structure that included a number for the state and the two numbers, which are the true combination numbers of the lock. Last, which is the last number that was sent, and a T for which is the cooldown. Okay, I wrote some updater functions that ended up, most of these didn't get used. So I guess the moral of the story is wait until you actually need them to write them. In my draw handler, I had a function to draw the colored circle, a function to draw a single number, and then I had a combination function that showed the right thing. The show the right thing function was kind of interesting because what you were supposed to show depended on the state that you're in, like how many of them were correct. And when do you show you only show the incorrect answer when you're in a state like 1 or 3, which is supposed to indicate that someone made a mistake and put an incorrect answer in. So after those helper functions, the lock draw handler wasn't too bad because it was just pick what to show for the combination and the state circle. Then the receive handler we just recently talked about. This one goes along with the picture of what's supposed to happen at what point. So if you're at state 0, then you're ready to fill in N1. Either goes to state 1, which is wrong, or 2, which is right. And repeat the same thing for 2, which either goes to 3, which is wrong, or 4, which is right. And if you get one of the wrong states, after 5 seconds, you get back to 0. Okay, and we tested it, and it worked. So everybody celebrate.